Good afternoon and welcome to the Society of Chemical Industry and our SCITalks series. Today we have the second event of a three-part series on sustainability, and our speaker today is Professor Rachael Ruthman, who will be talking about assessing sustainability, the good, the bad and the ugly of life cycle assessment. Can we have the next slide, please? Please, there's going to be a question and answer session afterwards, so if you can type any questions that you have into the question box when you're at any point during the talk, and then we'll address them afterwards. My name is Martin Elliott, and I'm chairing this afternoon's session. I'm a member of the organising committee for the SCITalk series. Okay, so can we have the next slide, please? Our speaker this afternoon is Professor Rachael Ruthman, who wears a number of different hats, including being Professor of Sustainable Chemical Engineering at Sheffield University. She's also Director of the South Yorkshire Sustainability Centre, a co-director of the Grantham Centre for Sustainable Futures, co-director of the UK Hub for Research Challenges in Hydrogen and Alternative Liquid Fuels, as well as being the academic lead for sustainability at the University of Sheffield. She's very much a thought leader in sustainability, regularly engaging with policymakers, the media and the public. Her research expertise lies in development and analysis of sustainable processes and systems. She has a background in large-scale hydrogen production and carbon dioxide utilisation, and has recently worked on the sustainability of foundation industry processes. Rachael leads projects that take an interdisciplinary whole systems approach to developing routes to net zero and zero waste, combining insights from engineering, psychology, linguistics, sociology, and the physical and biological sciences. She leads LCARSIM, the network set up to improve harmonisation in life cycle assessment, and it's used to inform policy decisions as we move to net zero. Born and brought up in Teesside, she graduated from the University of Cambridge in chemical engineering, and after a year spent in Sweden, she embarked on her PhD at the University of Sheffield. On completion, she became a postdoctoral research associate for 2 years, prior to becoming a lecturer in 2009 and a senior lecturer in 2014. Away from her academic life, she was a member of the British orienteering team for 16 years, ran 7 world championships, and has 2 gold medals at the World University Championships. Now, retired from international racing, she still loves to go orienteering and actively involved in coaching local and university athletes, as well as being a mentor on the University Elite Sports Performance Scheme. Rachael, good afternoon. Let me now let you have the floor and talk to us this afternoon about sustainability and life cycle analysis. Thank you.
Thanks, Martin. That was quite a lot of introduction. So now you know all sorts of different things that I do. And I guess what's key to all of the hats I have, which you can still see on the screen at the minute, is assessing the sustainability, because you'll notice that sustainability appears in quite a lot of them. And what we're actually going to do first is a little bit of quiz. So let me share this for you. It's just to make sure everybody's awake on a afternoon at 4 o'clock. Hopefully you can see the screen on the slide at the minute. So if you go to wooclap.com and put in SCILCA, it will take you to a voting page. I'll leave it on for a second. If you want, I mean, you're all on a device, so you can either go to wooclap.com or you can scan that QR code with a different device. And the code is the important thing, SCILCA. And what I'm going to do, let me flip to the first one. First of all, I'm going to ask you, which is more sustainable, a fizzy drink in a PET bottle or a fizzy drink in a bio PET bottle? And you should be able to vote. Let me pull up the results so we can see them as we go. That's nice to see it's working. We're getting some votes coming in. So please vote away. Which is more sustainable? I'll give you another 30 seconds to make sure you can get into it and you can put your votes in. I do like watching the bars grow as people follow the peer pressure of what other people have done and then add in their own thoughts as well. And we see how it changes up and down. How are we doing? We've had 25 votes. All right. Which is more sustainable? Well, I'm sure a lot of you are screaming, what does she mean by which is more sustainable? And quite often when we ask that, or when we are asked that, the way it's responded to is about carbon footprint. So if we take that first, because essentially we've made the same bottle, we've just done one via a fossil route and one via a bio route. So on a carbon footprint basis, currently, a fully bio-based PET bottle has a higher carbon footprint than a fully fossil-based PET bottle. And that is because your PET is made from ethylene glycol and terephthalic acid, and making ethylene glycol from a bio-based route has a lower carbon footprint than the fossil alternative, but making terephthalic acid has a higher carbon footprint if you're on a bio-based route because of all the processing that's needed in order to make the terephthalic acid. And that is the reason why on a lot of fizzy drinks bottles, you will see it tells you that it is 30% plant-based. And that's because PET is 30% ethylene glycol. And what they're actually telling you is that their ethylene glycol is plant-based and their terephthalic acid has come from a fossil resource. And so it's not as simple as the which is more sustainable, but hopefully that gives you an indication of the fact that you have to look at all the ingredients, not just some of them. And you have to think about the system. And of course, were they slightly different products we'd made, we might need to think about other things, not just about the carbon. For example, we might be thinking about impacts on the environment if it's littered or if it ends up where it shouldn't be. Let's go to the next question. So, which is more sustainable? A single-use carrier bag, a plastic bag for life, or a cotton tote bag? Vote away. Let's see what people think to this one. A single-use carrier bag, a plastic bag for life, or a cotton tote bag? I love asking these questions because in all the time I've asked questions similar to these, I've never had everybody answer the same thing. There's always a really nice split across what different people say. So let's see how we're going. The plastic bag for life is winning by quite a long way at the minute. Well, let me give you some stats. So if you use your single-use carrier bag just once, which in our house would never happen because they definitely turn into shoe bags and then bin bags and everything else. But if you were to use your single-use carrier bag just once, you would need to use your plastic bag for life approximately 4 times. And that's because it's thicker plastic. It has more material in it and it's roughly 4 times heavier. And that means you need to use it roughly 4 times as many times in order for it to be better. The cotton tote bag, you'd have to use in the region of 300 times. And if it's organic cotton, more like 700 times. And that's because of the energy and the water that's needed in the processing of the plants into a cotton tote bag. Now, I've done quite a lot of work with supermarkets looking at different bags. And actually what's more interesting here is not the footprint of the single bag, it's whether people reuse them the amount of times that they should. And what we found out surveying people at the checkout was that 40% of people had left their reusable carry bags at home, 40% of people had left their reusable carry bags in the car, and less than 10% of the people only actually needed the new bag that they were buying when they were buying it. So the key there is not what the bag's made of, but make sure you use the bag as many times as you possibly can before you get rid of it or before it reaches its end of life. Final one of these. What's more sustainable? And we have to imagine I'm in Sheffield at the minute with this. So is it more sustainable to have a bottle of Badois sparkling water, which is from the French Alps, or a bottle of Buxton sparkling water, which comes from the Peak District, which is somewhere around 15 miles from where I normally am in Sheffield? Buxton is winning at the minute. Is Badois making a comeback? No, it's still Buxton in the lead. Okay, let me tell you, on a carbon footprint basis, if I'm in Sheffield, the Buxton sparkling water actually has a higher carbon footprint than the Badois sparkling water. And that's because when you make that bottle of sparkling water, one of the biggest energy inputs is in the blow molding of the plastic bottle. And in the UK, we have grid electricity, which is most commonly used for that blow molding process. Whereas in the French Alps, more than 95% of the electricity is nuclear. And what that means is that the blow molding has a much lower carbon footprint. And that difference in the energy footprint of the blow molding is bigger than the footprint of the transport from the French Alps to Sheffield compared to Buxton to Sheffield. Now, I asked which is more sustainable. I didn't ask which has a higher or lower carbon footprint. Where the Badwar one loses out in an environmental assessment is if you look at something like ionizing radiation. So when you do a full life cycle assessment, you'll look at lots of different environmental impacts, one of which should be carbon or the global warming potential, but there's lots of other things to consider as well. And ionizing radiation is one we look at, and the Badwar bottle has a significantly higher footprint in terms of ionizing radiation because of all the nuclear electricity that's used. So which do we care more about? Do we care more about the carbon, or do we care more about the ionizing radiation? And how do we then decide which that makes more sustainable for us? And it's not just, as we said before, not just connected to the bottle, it's also very relevant about how we use it, not just in the production. And we have to think about who's using it, how you'll use it, and where we end up with in the end of life. Now, I'm going to stop sharing these and hopefully seamlessly switch over to my PowerPoint presentation. So we're going to talk about assessing sustainability. Hopefully what you've seen from those questions is that it's not as simple as answering the basic question, which is more sustainable. We really have to understand when we're asking what's sustainable, what question are we actually trying to answer? Are we looking at carbon footprint? Are we looking at all environmental impacts? And what we're going to go through today is some different ways we can assess sustainability, things to look out for, things to be aware of. And then at the end, please throw questions at me and I'll be happy to answer them. So that one we just looked at in terms of the bottle, lots of people answered that the Buxton would be more sustainable. And I suspect that's because the thing that came to your mind was it's closer, it's much less transport distance. And because the transport distance is less, it should be more sustainable. And if we were only looking at the footprint of the transport, that would be correct. But we had to look at the whole system in order to get the right answer. And what I'm often saying with life cycle assessment is you have to think about the whole pie, not just half of it. So we've got our first person here saying it's a red pie. Well, it could well be a red pie. But person two sees a different slice. It's an orange pie. It's a yellow pie. And everybody is seeing a different bit of the system. And therefore, what they're getting as an answer is different. And of course, if you put them all together, you'd be seeing a rainbow pie. And what that hopefully shows in my not amazing PowerPoint skills is that you have to think about the whole system in order to get the right answer. And if you only look at part of the picture, the answer might be right for part of the picture, but it won't be right for the whole picture. And when we're thinking about sustainability, we have to be asking ourselves, are we looking at what's most sustainable for me, or most sustainable for my company, or most sustainable for the world? And what question are we trying to answer? So how do we know that our product or process is sustainable or is more sustainable than something else? As well as environmental sustainability, there are other aspects that are also important. We're going to focus on environmental sustainability today, and we'll assess that through life cycle assessment or through material flow analysis, carbon footprinting, environmental risk assessment. But the economic and the social aspects are also important. I'm not going to really talk about those today, but I've put them up here to remind us that to be truly sustainable is not just about the environmental considerations, it's also about the economic and the social. And what's really important to do when you do sustainability assessment is assess all three of these things on the same basis so that they're therefore comparable, and we can look at a cost-benefit analysis across the whole system. Life cycle thinking is a mindset, and it's the most important thing that I'd like you to take away, if nothing else from what I'm saying today, is we have to think about the whole life cycle. And that is something that we should all be doing all the time, irrespective of whether we're a life cycle practitioner or anything else. We have to think about the whole life cycle. And the power of life cycle assessment is informing our innovation. And when it's done well, if you're designing a new product, doing some research, if you iteratively do a life cycle assessment along with that development process, you can understand, where are my hotspots? What do I need to improve? Then you can make some technological developments, you can make some advancements, and then you can assess again, how's that changed my life cycle impacts of the product or process that I'm developing. So when it's done well, it can inform that development process and it can help us move towards net zero. Life cycle assessment all too often is done either just at the end of a development process, or is done badly, or is reported badly, at which point it generates and spreads greenwash. So hopefully through what we're talking about today, you'll have some understanding about how and why greenwash might creep in and how we'll avoid that. And before I go into full life cycle assessment, I just wanted to mention that carbon footprinting is a small part of life cycle assessment. There are ISO standards for carbon footprinting. It follows the LCA guidelines, but it only focuses on greenhouse gases. It's much quicker and easier to do, but it doesn't give a holistic picture. So if all you want to know about is carbon, you only need to worry about these ISO guidelines, not the rest. But if you're actually looking for that full holistic picture and to try and avoid unintended consequences in other areas, we might need to do a full life cycle assessment. So for anyone who's not familiar, in a full life cycle assessment, there are stages which are defined by the ISO 14000 series. And the key ones to look at are the 1440 and 1444. So first of all, we define our goal and scope. And the goal is about what question are we trying to answer with this? And the scope is about what's included or not included, what assumptions have we made, what allocation procedures have we made, and what are the limitations of what we're looking at. And once you've done that, you can collect your data. That's called the inventory. So there might be primary data collection. We might have background data that comes from databases. And the important thing there is to consider what quality of data is needed and how that impacts our results. So then we do the impact assessment using an assessment methodology. And then the interpretation is also really key. And when you interpret results, particularly if it's not an LCA you've done yourself, it's important to know what questions should I be asking? What should I be aware of when I'm interpreting the results? What assumptions are these results based on? Because if the assumptions were different, in all likelihood, the results would also be different. And the ISO 1444 is the one which covers the critical review, which is about making sure that a life cycle assessment has conformed to the ISO standard. Now, I think it's important to say here that you could compare more than one product, essentially the same thing, and get very different answers and still be ISO compliant. And this is where transparency is really critical to explain the assumptions that have been made. And to illustrate this, the graph you can see on the screen now is the climate change, the global warming potential of a series of different plastics. The blue ones are all bio-based, the orange ones are fossil-based. This is from a literature review looking at people who've used the methodologies to do life cycle assessment, and it's looking at whether they comply with the product environmental footprint, which is an EU methodology for LCA. And what you can see in those bars is the variation in published LCA for 1 kilo of that particular plastic. And some of them vary by more than 400%. And that's because of differences in data sources, differences in system boundaries, differences in methodologies, and all of those things will then impact the results. And if there isn't transparency of what's been assumed and what is and isn't included along the way, then you can quite often end up trying to compare two things that are not comparable. And this is why it's so important not just to take a number or an answer for an LCA and try and compare it to another number from another LCA, because they might be based on slightly different things. And sometimes those differences can be quite nuanced, and that's why it's important to understand what questions to ask when we look into it. So let's have a quick look into system boundaries. Here is a very simple process. We've got a primary production that's often called the cradle. So when you hear about LCA, you'll often hear people talk about cradle to grave or cradle to gate. And cradle is the making the thing in the first place. Let's start from a raw material. And in this example, we're going to use it and we're going to get rid of it. That's our grave. And that's quite simple as an LCA for that product, because if we're going cradle to grave, we include all three of those boxes and we don't have to think about anything else. Now let's make it more complicated and think about what happens if that product doesn't straight away reach its end of life, incineration, landfill, something like that. What happens instead if it's recycled? And I've borrowed this diagram from the reference that's in the bottom there. And the kind of grey and blue boxes you'll see stay the same. But now we've added two boxes in the middle where we're doing some recycling. We're going to use that recycled product and then it meets its end of life. So this is now a kind of two-stage life process. It has two different uses. And there are three different ways that we can draw our system boundary here. One is what we call the cutoff approach. And so if we're thinking about our primary product, in the cutoff approach, we look at making it and we look at using it. And if it was going to waste, we'd include the waste. But if it's going to make another product, we don't think about the rest of it. In cutoff, the recycling process would be attributed to the second product that's being made. So that's your cutoff approach. We've literally cut it off at the end of the use of the first product. The middle one there is your APOS, which is about substitution. So in this one, we make it, we use it, we pay for the recycling from an environmental impact perspective. But then let's imagine it's a plastic product here. At the end of recycling, we've made some granulate. And what we get to do is we get some credit for the fact that we've made something useful that we didn't have to start from a virgin material. So we can credit ourselves with the avoided burden of making that thing to start with. So this is your APOS method, and effectively we're now including all of the recycling, but we're getting credit back for doing it. And they're almost, the cutoff and the substitution approach, they're polar opposites to each other. One, we cut it off completely, the other, we pay for it all, but we get credit for what we've done. And the final one on the right is the PEF methodology, which is the environmental footprint. So this is the EU methodology. And it's written as 50-50, but there are guidelines for different product areas for this. And this says if a product has, for example, 2 uses, then the primary production should be 50% allocated to the first use and 50% to the second use. So both uses are paying for the production, they're both paying for a bit of the recycling, and they're both paying for the ultimate end of life. Now, all 3 of these on the screen are perfectly valid ways to do a life cycle assessment. And you would find when you read them that this uses the cutoff approach, or this uses the APOS approach, or this uses the 50-50 PEF allocation. But as you can probably imagine, all 3 of these would give you very different answers. And so what you ideally would do in a circumstance where you have recycling like this is you might use one of the methods, and then you might look at how it would be different if you used a different method, or if you used a different split that wasn't 50-50. And this is where some of the challenges with comparisons come, because you really have to understand what wasn't and wasn't included in order to do that comparison. So I'm going back to bags. We talked about bags earlier in our little quiz. And here is a reusable plastic bag. And this plastic bag it's not actually based on an Asda bag. That was just a picture I found. So it's a plastic bag for life. And the main body of the bag is made from recycled back of store plastic. But the handle is made from virgin plastic in order for it to have the structural integrity that's needed for a handle. So in the blue boxes on the left, you can see the primary production of my first plastic. You can see my plastic bag making. And then on the second line, you can see the primary production of the second plastic that's then been recycled and has gone into it. And in APOS method, even though that back of store plastic might have had a previous life, we have to pay for all of that. We have to pay for making it and disposing it and recycling it. So we're paying quite a burden there for using that recycled plastic. The use is in a dotted line because I haven't included any impacts for use in the results I'm going to show you later on. And then we've got the disposal, incineration, recycling, and you can see we're getting some credits into our system. So this incineration is assumed to have energy recovery, and our recycling gives us some granulate, which we get avoided burden for. So that's our APOS approach, our allocation at the point of substitution. And our alternative is the cutoff approach. So here, the 2 diagrams were the same, and what you can see is some of the boxes have vanished. So we've literally cut off the beginning and end, and we're looking at the primary bag making and the disposal only. We don't get any credit, but we also don't have to pay for the primary plastic that went to recycling. Now, I'm going to come back to that example in a minute to show you the results. First of all, we're going to take a quick diversion about co-products and multifunctionality. And what we mean there is what happens if we're using something for more than one reason, or if we're making either using 2 things to make something or producing 2 things. How do we then allocate those things? So within the ISO standard, there are some rules that we should follow. The simplest one says, if you're making 2 things, if you can just split your process down the middle, because part of the process makes one thing and part of it makes the other thing, you subdivide it and you don't have to worry about it. The second one is we should expand the system to include more, and I'll give you an example of that in a minute. And if you can't do either of those, you allocate, and we're going to talk about allocation as well. So let's come back to our plastic bag. we've got a reusable plastic bag. That's your APOS model. There's our cut-off approach again that you saw before. Now, what we're going to do is compare this to a reusable paper bag. I'm sure lots of you have seen supermarkets start to switch. There's been lots of debate about which one's better and why. Well, here's our reusable paper bag. In this case, it's a virgin paper source. It comes from trees. We're going to make the bag, and at the end of life, we're going to predominantly recycle it because paper bags have a high recycling rate, and we'll get some avoided material production. Now, I could just compare that paper bag with the plastic bag we had before, but you might remember me saying that that plastic bag was predominantly made from back of store plastic. If I switch and use a paper bag instead, what would happen to that massive mound of back of store plastic that I used to be processing to turn it into bags, but now I'm not processing it to turn it into bags anymore? So I've changed something else in the system, and this is about thinking about the consequences of your actions. So should I also include the making of that back of store plastic, the disposal of it, the recycling of it, and the credits that I would get from it? Because that means that overall, I'm still looking at the same system. So if we look at, let me put up all the words, there we go. If the top one there is the results from APOS, so the allocation at the point of substitution, not including the plastic film. And in each of these examples, the plastic bag is the greeny coloured one and the paper bag is the pinky coloured one. So you can see if I just compare, just let's make a paper bag and just let's make a plastic bag. I've only put water consumption and global warming on here. And I've normalized each so that the worst one is 100 in each case. So you can't compare water and global warming on this graph, but you compare the two colors within each graph. So what you can see is that the paper bag on its own has a much lower carbon footprint than the plastic bag on its own. Now, if I also include that, well, I still need to process that back of store plastic that I had before, that then gets you to the middle graph. And what you can see is that, yes, the paper bag still has a lower global warming footprint and a lower water consumption, but it's much closer now to what the plastic one is. And that's because we've processed the back of store film in both cases. And the final one is, what if we use the cutoff method? And what you can see there is that the paper bag is still better on global warming, but on water consumption, all of a sudden the paper bag is worse. And that is because in the cutoff method, we don't have to pay for the plastic that's made at that gets recycled, that goes into the body of the bag, but we do have to pay for the virgin paper that's going into it. And paper production involves a lot of water. If you've ever been to a paper factory, there's water everywhere. It drips off every surface. And so the way the cutoff method works means that the water consumption is now much greater because of what is and isn't included. And what this tells you when you're doing analysis, particularly for water in this case, is it would be really important to look both at your APOS method and your cutoff to get a more accurate picture of your water consumption. And you need to understand, what is it that I'm trying to answer? Am I just looking at the bit of the process I'm responsible for, which is the cutoff? Or am I thinking on a more global level, which is more APOS? And then, of course, I haven't put the results up for the 50-50, but that would give a different answer again. Okay, let's move on to how do we allocate impacts. So let's imagine I am growing a field of wheat, and that wheat, I'm going to process it, and I'm going to turn the kernels at the top into flour, and I'm going to make a kilo of flour for the sake of argument. I know this is very simplified. And I'm going to get a kilo of waste straw. And on a mass allocation, I would allocate my impacts 50-50. So all the impacts of the fertilizer and the growing the wheat, they're 50% going to my flour and they're 50% going to my straw waste, because I'm making 1 kilo of each. So that's the same amount, it's 50-50. And that's one way that we could allocate the impacts of growing the wheat. Now, what happens if we do an economic allocation? And I'm going to say at the moment, for the sake of argument, my flour costs £2 and my straw, it's a waste. I'm not getting any money for it. It has no economic value. So if I allocated the impacts of my wheat growing on an economic basis, all of the impacts would go to the flour, because the waste, I'm saying, has no economic value. And this is where you get into some challenges of what is a waste, how much impact should it have allocated? And things like energy from waste become really interesting in the carbon accounting about what impacts are allocated to it if it's a waste. Now, what happens if instead of getting rid of the straw, the waste, now I'm going to make a bioplastic with it? So I'm going to take that straw, I'm going to process it, I'm going to make a bioplastic. And let's pretend that I can sell that for £3. Now on an economic allocation, my flour is only getting 40% of the impacts and my plastic is getting 60. Now in every one of these three cases I've just shown you, I'm making the same amount of flour. But in one case, it got 50% of the impacts. In one case, it got all the impacts. And in another, it got 40%. So which is the correct answer? Well, they're all correct. They're just done using a different methodology. And this is why understanding of methodology and transparency of the methodology that's been used is really, really important. And any life cycle assessment we do should include a sensitivity analysis. So if I was doing this for a part of a research or as a part of a consultancy, then what would be correct to do would probably be to say, on a mass allocation basis, this is what the results look like, and on an economic allocation basis, allocating in this way, this is what the results would look like. Because what you can see is that they'll be different in all likelihood in each case. A quick dive into data and assumptions. One of the most time-consuming bits of LCA is gathering the data that's needed. And the data quality is really key. And you need to understand upfront what quality of data do you need. So we often talk about representativeness. What geographical representativeness do I need? If I'm looking at making a product in the UK, then my raw materials, my energy should all be UK relevant. I don't want to use average for the whole world because it wouldn't give me a representative answer. You often also will hear people talk about a foreground system and a background system. So the foreground is the bit of the process that we're really focusing on. We might have some experimental data there or some operational data there. And a background system might be upstream or downstream in the supply chain, the bits you don't really have control of. It might be much harder to get the data, and you might use data from databases in order to plug some of those gaps. And understanding the quality of that data is important. And if there's always in an LCA, you have to make assumptions. And what's good practice when you make an assumption is then to say, if that assumption was bigger or smaller, 10%, 5%, whatever's reasonable, how would that change the results? And sometimes you find it doesn't change the results hardly at all. And other times you'll find it has a massive impact on the results. And you need to therefore be aware of those assumptions. So here's an example on transparency for you. I was asked a while back to look at some life cycle assessment of milk packaging, looking at published LCAs. And back in 2010, RAP had done a report. And one of it was really well done in terms of methodology, but the conclusion they had was that the data quality was not high enough to make comparative assertions. And it was actually really nice for me as someone looking at LCA to see someone being honest and say, look, here's all the LCA we've done, and they get all the numbers. But in their conclusion, they're not saying one is better or worse than the other. They're saying that the data is not good enough in order to make a comparative assertion at this time. And then some years later, there's a report by a consultancy which Tetra Pak commissioned. And that concludes that Tetra Pak, probably unsurprisingly, given that Tetra Pak have published it, has a lower carbon footprint than an HDPE milk bottle. And when I looked through it, it's quite a long report. I looked through it. I was impressed with their methodology. They're very clear about what they've done and how they've done it. They do use average European data, and so it's only really applicable for an average European market. And if you were looking at a specific location, you might want to look at more geographically specific data. The crux came when I got to how the end of life was modeled, and it's modeled using a substitution factor. And this is about how much of what goes to recycling ends up then being used again as the same thing. And they use a value of 0.8 for HDPE, which says 80% of the HDPE goes to recycling, will go back into HDPE. But they use a 0.9 for the paper fibers in Tetra Pak. And that, in effect, is saying that 90% of them go back into paper fibers. And the challenge there is that actually those paper fibers don't go back into Tetra Paks because they don't have the right fiber length. So what often happens with those paper fibers is that they go into things like plasterboard. So the conclusions they have come to are perfectly valid for the assumptions that have been made, but they are only valid taking into account that assumption. And those assumptions are buried somewhere in the middle of the report. So if you're looking at LCAs that have been published, the caution I would give you is to make sure you understand the assumptions that those results are based on. And if you're writing LCA or reading something or commissioning something, really encourage that transparency to make it clear what assumptions sit behind the work. And I think quite often when we do LCA, we want to have an answer, but actually that answer is only valid based on the assumptions that have been made in order to get there. So this brings me on to interpretation of results. And here's an example that says, when does reuse make sense? And it's some work we've done on a living lab at the University of Sheffield, looking at what happens if you switch from a single-use food container in cafes to a reuse container. And the pink line on this graph is single-use containers, and the grey line is the reuse container. And the thing with the reusable one is it's obviously used, ideally, lots and lots of times. So what's key with reuse is what is the break-even point? How many times do I need to use my reusable container for it to be better than a single-use container? And that point is where these two lines cross on the graph you can see in front of you, which is at 60 uses. So this particular reuse container, you would have to use 60 times. And what we then looked at was, well, if we were trying to redesign that container or design it from scratch or design the system, what would we need to do? So this graph gets a little bit complicated, but the yellow line is keep the same container, but now let's use renewable electricity instead of UK grid for our cleaning. And the break-even point slides down to 40 if we switch to renewable electricity. Let's go back to our normal electricity, but let's recycle, and it's predominantly polypropylene, this container. Let's recycle it at end of life. Our break-even point will be 33. And if we lightweight the container, these are quite chunky at the minute. If we lightweight it quite significantly, you could get down to, say, 13. And if you combine all three of those things, our break-even point would be 5. So what you can see here is some help in designing the system that says, what does our system ideally need to look like in order for our break-even to reduce? And that sensitivity analysis is really key. And all good life cycle assessments should have sensitivity built into them to see how the results would change as you change the assumptions you make. And here's a bit of an aside. So those numbers you see on the screen are the ones I was just telling you about, options for our design system. But key to this is not just the life cycle assessment, because you can design any system that is, in theory, environmentally better than something else, but it's only actually better if people will engage with it. So what we did was work with the mechanical and materials scientists and engineers and the psychologists to develop a methodology for assessing what is the willingness threshold. So the materials scientists took a whole load of bowls, they basically wiped them with wire wool, microwaved them with tomato soup, and every cycle they went through, they took a photo of it. And we have this whole matrix of photos of bowls that gradually get more orange as they're filled with tomato soup or curry or something else more and more times. And then the psychologist showed those pictures to people to say, would you use this or would you use this? And it's a stepwise progression. And for the worst case scenario, the willingness threshold is only 7 to 9 uses before you get to the point where people say, I wouldn't eat out of that anymore. Things that LCA doesn't take into account is microplastics and littering. So in that example I just gave you, neither of those things were looked at from the plastic perspective. And methodologies are being developed, but there's still a lot of work that needs to be done on those. I'm going to skip through this a bit because we seem to have lost a bit of time, and I want to give time for questions. So quickly on biogenic carbon. As we move to a more bio-based world, accounting of biogenic carbon becomes really important. So the top graph there is looking at a fossil-based item, and your carbon footprint will increase with extraction, refinement, manufacture, use, and end of life. With a biogenic item, you obviously take in carbon as it grows, but then as you harvest, manufacture, use, and go to end of life, carbon will be given out again. And depending on the gradient of all of those lines in that diagram, your bio-based material could end up having a higher footprint than the fossil one, an equivalent one, a lower one, or even potentially a negative one, depending on the gradient of all of those lines along the way. So we have to really be careful with bio-based things about the allocation, as you saw in my earlier example, the scale and the scale up, And also, if it's a plastic item, what are the stages of decomposition and what might happen? What about microplastics? How does it impact the soil, etc.? So we've done some work looking at challenges in LCA for bio-based plastics, and the pie charts there are the results of a survey. So what do people in the field feel? And overwhelmingly, people feel that the standards currently favour fossil-based material rather than bio-based ones. And the reason for this is that LCA impact categories have been around a long time, as have fossil fuels, and things like litter and microplastics that might benefit bio-based materials are not currently included in the impact assessment that we do. And including those would potentially change the balance. And so there is work ongoing, and we're doing some work on harmonisation to look at how we can make sure all of these important things are included to avoid any implicit bias that might otherwise be in place. Another challenge, and I mentioned this just now, is that bio-based products, generally use of them is not as widespread. A lot of them are more at pilot scale rather than big industrial scale. And as processes scale up, the footprint per amount used will also change. And so we have to do things like prospective LCA, which is looking into the future, or ex ante LCA, which is looking at scale up, to consider, well, how would the footprints change as these things change over time? We can currently get a reasonable picture of carbon associated emissions, but other things also need work, and things like land use change methodologies are still being developed and improved all the time in order to assess what the impacts of the land use are and might be. In the interest of time, I'm going to skip over the composting one, and let's just quickly look to the future. So I mentioned about the interest in the gradients of the lines here. So what we've done is look at future energy scenarios, and those lines you can see on the screen are the DESNZ predictions of how the grid emissions of our electricity grid might change over time. So you've got a DESNZ prediction, a simplified DESNZ prediction, and a what happens if we get to net zero prediction. And currently we use a lot of gas, natural gas, for our heating. What would happen if we used hydrogen, either from SMR, that's the red on there, or from electrolysis with renewable electricity, that's the blue. And this isn't considering at all the availability of that hydrogen, just if you could have hydrogen from green hydrogen, how would the footprints change? And if I zoom in here, this is for PET, and we've done lots of work looking at different comparisons. The solid lines are all bio-based and the dashed lines are all fossil-based, and the colours match each other, so we're comparing different things. So if you look at heat coming from natural gas, the solid green line is always higher than the dashed green line. And that means that for bio-based PET, if your heat sources needing in the processing rely on natural gas, your bio-based one will always have a higher footprint. But as you start to move to hydrogen-based resources, you'll see your solid line crosses over your dashed line. And this is why with life cycle assessment, it's really important not just to look at what is the environmental footprint now, but how would it change over time? And particularly when we're looking at products and processing, how will it change over time as our electricity grid or our energy provision changes and becomes lower carbon? And what you can see here is if you use green hydrogen, then already bio-based PET would have a lower footprint. And if you use hydrogen with steam methane reforming, then by 2025, it should have a lower global warming potential. So this is my takeaway messages to avoid greenwash and to do fair comparative sustainability assessments. One is clarity. So what question are you trying to answer? And make sure you use the methodology and the assumptions that are needed for the question that you are trying to answer. The second is transparency. What has been assumed and why? When are those assumptions valid? And what's the implication of those assumptions? Clear system boundaries, what is and isn't included in the assessment that's been done. Limitations, is the data robust? What's the uncertainty? What would you do if extra data were available? How would it impact the results? And I've put peer review there at the bottom, and I think this is important from a confidence for other people to have confidence in life cycle assessment, is making sure that it's reviewed to ensure that the correct methodology or fair assumptions have been made along the way. I'm going to stop there so I can answer questions. I've put my email address on the bottom, and I've also put the website for the Life Cycle Assessment Regulatory Science and Innovation Network which I lead. And this is about how we use life cycle assessment to help inform policy and regulation. So we're working with lots of people across academia, business, industry, and across various government departments, predominantly DESNES, DEFRA, DFT. And it's about how do we use life cycle assessment to provide the evidence so that when we have policy and regulation, we think, yeah, that's a good thing. That'll make a difference if we put that in place. And that web address at the minute will just take you to a holding page to join the mailing list. The main website will be live within the next few weeks, and we'll let you know. But if you sign up to the mailing list that's on that web address, then there'll be a newsletter coming out to tell you when everything else is happening. And there will be an annual life cycle assessment event for anyone interested in Sheffield on the 19th of June. So hold that date, 19th of June, to get everyone together to talk about life cycle assessment across all sorts of industries, methodologies, lots of different very fun things to talk about. And that really is, I'll stop talking and answer any questions.
Rachel, thank you very much indeed for that. A very interesting discussion. Okay, if you've got any questions, I'm sure that there are within the audience, please, if you can put them into the question and answer box, we will attempt to answer them for you. But no, felt quite pleased at the start when you were doing your questionnaire about single-use lifetime bags and the cotton tote bags, and you gave the number of times that things had to be used, because my cotton tote bag I would estimate to be used at least 700 times by now, so I can feel good about that.
Oh God.
Yeah. Okay, we've got our first question come through here. We've learned that the assessment is complex. Does that make it expensive? Could it be too expensive to be practically used? And that's come from John McFarlane.
So it can be expensive, and I think the key here is you only want to do a full life cycle assessment if you need to do a full life cycle assessment. And I was at the symposium earlier on, and I was talking to a good friend, Katie, who's based at Unilever, and they have an internal team who do loads of life cycle assessment. They can tell you the footprint of an example of every chemical they make, thousands of products. They don't publish that. They use it for their own internal use, and they obviously put resource into doing that. They also sometimes do LCA, which is then reported to the public, which they might pay an external practitioner to do. So the level of LCA you need really depends on the question you're trying to answer and what you're trying to use that LCA for. So if you want an independent LCA that is peer reviewed, yes, you will pay for it. And I see someone else has said, how much does an LCA cost? That's a bit like a how long is a piece of string question, because it depends on the complexity of the system that's being assessed. I've done LCAs on reasonably simple systems that have cost 2 or 3K in order to do. We've also done massive research projects that have cost tens of thousands of pounds that are on much bigger, much more complex systems. So it depends on the availability of the data, the complexity of the system, what is and isn't included. And this comes back to, what question are you trying to answer with your LCA? What is the goal of doing it? Do you need to do a full LCA? Do you just need to do a carbon footprinting? And yeah, pick the one that makes sense for you. I don't think it makes it too expensive to be practically used, but you have to be answering a question that makes sense to be answered using LCA.
Let's go on to the next question. If hydrogen lowers the carbon footprint, what does it do to the price?
Yes, and this comes back to one of those very first slides when I was talking about you need to balance the economics and the environmental considerations, because at the moment, green hydrogen is more expensive than natural gas. And so, yes, it will reduce your carbon footprint, but yes, it will make it cost more. And it depends on what your source of green hydrogen is. It depends on all sorts of things. That will also change over time, because right now, we're not really penalized for our carbon emissions, but at some point in the future, we will have carbon pricing or carbon taxation. And what makes sense when really depends on what that carbon pricing structure is and when it comes into play. And something that a lot of people have been pushing government for is clarity on when we'll know about that and what the likely pricing or taxation regime might be.
Maurizio Davila, I hope I pronounced that correctly, asks, are there specific consultancies providing services exclusively on LCA of chemicals and polymers? Or
There
possibly,
are lots of consultancies who provide LCA services, some of whom, yes, specialize in chemicals and polymers. And if you want, get in touch with me separately and I'll send you some suggestions.
Next question. We were told that comparative studies across PCR are not valid. We have an alternative technology that solves the same problem. We need to be able to compare. What can we do?
I'm just reading the question. With comparative studies across PCR are not valid. Well, it depends how you're it depends who you're trying to answer the question for. So if you're just trying to answer the question yourself, then a comparative study would be valid. If you're trying to answer a question from a regulation perspective or from a EPD or something, then you need to understand what basis you're doing it on. And that some of the things I showed you earlier on about you can do comparisons, but they're not really fair comparisons, is where this really comes in. So yes, you can do comparative studies that will be valid, but it depends what you're trying to have that comparative study for. I'm not sure that's totally answered your question, but hopefully it's moved it forward a bit.
Okay, thank you. Let's so we've only got 4 minutes left. Let's move on. One of the main challenges you have highlighted is comparison of LCA data from different suppliers who may have used different databases or methodologies. Do you see further standardization as a solution for better, more accurate comparisons to be drawn?
Yes, and it's not, well, yes, but it's not just about more standardization, because we have ISO standards, but as I said, within the ISO standard, you're free to make your own choices about allocation and assumptions and everything else. So rather than standardization in terms of having more standards, it's maybe about harmonization and guidelines about what values should be used within all of those possibilities. So there are already guidelines in some sectors that would say, for example, there's a whole series of guidelines for carbon capture and utilization that suggest values that should be used when you're doing analysis in that space. And lots of other sectors, I think, would benefit from equivalent guidelines to help people use values which then enable things to be compared. So it's probably more about guidelines for harmonizations within specific sectors than it is about standardization across the board.
What do you see as the risks and benefits of carbon footprinting versus full life cycle analysis? What are the greenwashing watchouts in this approach?
Yeah, and whether you need to do full LCA or just carbon depends on what things you're comparing. Quite often, the big thing to watch out for is unintended consequences. So you might do something which has a lower carbon footprint, but it might have a much higher ecotoxicity, or it might have a much higher eutrophication potential or something else. So the danger is that you end up making something else worse. And if you don't do the full LCA, you don't know what some of those unintended consequences might be. So that's the kind of danger in terms of greenwashing. And I think it's about understanding the question you're trying to answer to know whether it's important to look out for those other things or not.
We've got three more which we can hopefully squeeze in. Do the current regulations take account of the complexity you have demonstrated? How difficult would it be to make them better?
Oh, that depends on what regulations we're talking about. So no, probably not, but I mean, it depends on the regulation. And I think it's about us using good data in the assessments we do, being transparent about our assumptions. And if we want to be comparative, it's about following guidelines or being involved in developing those guidelines to make sure that we can then compare things.
One of my fellow colleagues on the organising committee is asking the next question. David Bott, what will LCA SIN do?
Yeah, so this is the LCA Regulatory Science Innovation Network. There's several different things happening, and the web address I put up before will soon take you to a website to explain it. But we have working groups which are looking at developing harmonization guidelines, looking at where data is and isn't good enough, where do we need better quality data in order to make assessments? How would that data be available, etc.? We've got one looking at biogenic carbon and recycling and how we have better information and methodologies there. One looking at harmonization and guidelines around methodologies. We've got one looking at skills. What skills do we need in LCA? So is it more of things like today to get people aware of things to be aware of, or is it about deep dive for practitioners, what skills are needed? And one looking at practice and accreditation. So how do we give people confidence in the life cycle assessments that they look at? And we also have special interest groups which you can join to have discussions on areas you're interested in. So there's one on social LCA and there's one on policy, etc. But what will be achieved is there'll be a whole series of kind of white papers and briefing things, and all of those working groups I just mentioned have policy officers from DESNES and DEFRA on them, so that all of this methodological discussion feeds directly into how can we help provide evidence for policy and regulation.
And the final question we have here is, what is the biggest change that you think everyone should make that your use of LCA has revealed?
Ooh. I think the really key thing for me, well, it's the things that we had on the last slide. One is we always have to apply life cycle thinking. Even if we're not an LCA practitioner, we should always, in everything we do, in all of our roles, be thinking not just about our little bit of the picture, but think about the whole picture. And what else do we need to be aware of or be cognizant of or think about? And that doesn't mean we have to be able to answer it all ourselves, but we have to know what questions we should be asking. We need to make sure that we're transparent in any LCA we do. And I think for all of us who might be looking at LCA, it's to be able to interpret the results with a healthy skepticism that doesn't just take a number and then repeat that number, but says, well, why is it like that? And is it because of an assumption made? And so use that kind of healthy skepticism to evaluate the usefulness of the results that get published.
Can I remind you of one of the early slides you put up where you had the following phrase: life cycle is a mindset.
Indeed.
Rachel, many thanks indeed, and thank you to all the members of the audience. I'm sure everybody will have found that a very, very interesting way to spend an hour this afternoon. But just also to refer to something that Rachel mentioned, and that is on the 19th of June in Sheffield. Please look that up and get something into your diary. Okay, now on the 30th of April, we will have the final talk in this series on sustainability, the role of advocacy in accelerating the transition to more sustainable chemicals. And then we take a break over the summer and we start again in September on regenerative agriculture. What does it mean for farmers, policymakers and citizens? And on that, I'll say thank you once again, and have a good afternoon and a good evening. Thank you to everybody. Bye for now.